Hey everyone, Andrew here. This video will be relatively quick and simple. I'll be showing off how to build a Google Chrome extension from scratch using Vue to provide interactivity with Chrome's extension API. The extension in question will be used to block a list of websites whenever a toggle has been turned on. Let's dive right in. First things first, what do we need to create an extension? Well, at an absolute bare minimum, we need a file called manifest.json. I have one right here in a local directory, so let's open it up. This file provides all of the metadata for our extension, as well as the permissions and scripts that it requires to install and run on a browser. Adding in a name property, we can title our extension. This will show up in both the extensions window and the Chrome Web Store. A version property containing the current version of your extension. A description describing what your extension does. And finally, manifest_version set to 2, the current requirement for new Chrome extensions. Let's save this and head back to our browser. On the extensions page, check the developer mode option at the top right if it isn't already active. This will display an additional header with a few new options. The one that we're going to use is load unpacked. This expects a folder, so let's navigate to the root directory where our new manifest.json file resides. After hitting select, you'll see your extension, with the name, version, and description provided earlier, appear in the list. We can pin it to our toolbar up top, but it doesn't really do anything. We can click it, but it just shows a context menu with a few generic options. What we want is some kind of window to display where we can add in sites to block and toggle the active state of the extension. Heading back into manifest.json, let's append some lines to this config file. Browser action, and that's an object containing default popup with a value of popup.html. Let's create that file and open it up. Some pretty basic sample text should work for our testing purposes. A title, and a little body content. Okay, that looks good. After each change we make, in order to pull this into the extension installed in our browser, we just hit this refresh button. So now if we click the extension next to the URL bar, we can see the pop-up with the HTML that we saved earlier. The size of this pop-up window is dependent on the wrapper element that contains it. So if we go back into the popup.html file and pull all of this into a div, and specify the width to say 480 pixels, when we go back, refresh, and open the pop-up again, we can see that it's set to 480 pixels wide. Okay, so now that we know about the basics of displaying HTML in a pop-up, let's expand on this a little bit. I'm going to scaffold out a basic layout for our site blocking extension. The title isn't really necessary here, but I'll add it in anyway. And we'll be styling this pop-up with a style sheet called popup.css under the CSS directory. We have our wrapper div, add in a title, some buttons, an area to hold the site's block list, and finally a button to save the list of sites. Saving this and refreshing our extension, we can see what that looks like now. And it's not bad, but it's unstyled, so let's fix that. Let's create a directory called assets sas, and inside of it will be a single file, popup.scss. I'm going to take a shortcut here and just paste in a bunch of styles that work well with the markup that we've added earlier. Now, this being a Sass file, we need to compile this into plain CSS. I'm going to be using Laravel Mix for this, so we'll need a package.json file at our project root in order to get started with that. It's a private project. And for our scripts used, I'm just pulling in from the main Laravel Mix example. Using the terminal, I'm going to install and save Laravel Mix, Sass, and some other supporting packages as well. Okay, that finished up nicely. So the next thing we need to do is create our Webpack config file, webpack.mix.js. let mix equals require larval mix, set the public path to our current directory, and compile our popup Sass file to a dist CSS directory. We'll also add in this process CSS URLs option as false. This helps prevent font or image files from being added in automatically. I don't think we have any with this project, but I like adding this in whenever I use mix with Sass. So now we just have to run npm run dev in the terminal. Alright, once that's done, we have to go back and update the style sheet path in our popup.html file, since we ended up exporting our CSS to a dist directory. I'll show you why I chose to do this. If we go back and refresh our extension again, we're met with an error. Clicking it, we're alerted to the fact that our extension contains a key file, found in the node modules directory added when we ran npm install. And if we go back and look at the details of our extension, the size has ballooned to over 100 megabytes. This is because we're including that entire node modules directory in our extension when we don't need to at all. We just need to include the compiled assets, manifest.json file, and popup.html. So let's uninstall this extension, go back to our project in the IDE, move our popup.html file and manifest.json file into the dist directory, and adjust the source of the style sheet, removing the dist directory. This will be the point of entry for our extension, instead of the entire project root. Going back into Chrome and clicking Load Unpack, let's choose our dist directory now. We don't see the errors anymore, our plugin size has been reduced to under a megabyte, and our styled popup HTML is looking perfect. Okay, so now that we have a styled popup displaying, we need to actually add some functionality to it. If we open back up our manifest.json file, under the description, we'll add a new attribute called background. This can contain a few different attributes nested in it, but we're going to focus solely on scripts, and include a single one called background.js. What this does is pretty self-explanatory, telling the extension what JavaScript should be ran in the background whenever the extension is active and installed on the browser. We also need a few permissions to use this extension properly. Storage, web request blocking, and wildcards of every insecure and secure site that the user visits. After that's added, let's create that background.js file in assets.js. There's a few things that we need to do in here, mostly with Chrome's built-in events that we can hook event listeners into. Whenever the extension is installed for the first time, we should set some default values, like the active state and the list of sites that are blocked. Chrome runtime on installed, add listener. And for the invoked function, we're going to use Chrome storage sync set, passing in an object consisting of the two properties that we're going to use throughout our extension. Toggle sites active, a boolean, by default will be set to false, and toggle sites list, a string, by default set to just example.com. Set is an asynchronous function, meaning that it expects a callback as the second parameter, which contains either an error or the storage items that were set. I'm not really keen on doing anything with either of those, so for this example, we're just going to return back an empty function. As a note, we're also using Chrome storage sync here, which means that any values that we set are available across all browsers signed into the same user account for that extension. The alternative to this is Chrome storage local, which sets those values only on a single browser. After that's set up, we'll have to do something a little hacky in order to pull in the values that we want to our extension without any hiccups. I'll explain why as I go. First, we're setting some variables here with the same name and values as the ones that we set in our onInstalled listener. Next, we're using the Chrome storage sync get method to pull in an array of values from the storage API. Again, we're using the same names as the ones we've been referencing, toggle sites active and toggle sites list. Just like the set method onInstalled, this is an asynchronous function, and the second parameter is a callback with the result set from the browser's storage. After this resolves, we're replacing the global scoped variables with the results from the browser storage. Result.toggleSitesActive and result.toggleSitesList. So the reason that we did this is because of the fact that storage sync get is an asynchronous function. It doesn't block the script processing, and instead waits in the background for a resolve. But our extension needs some values to start with. Otherwise, we'd be met with errors on our extension screen or in our extension's console log. Even though the lag here is less than a second, this is a workaround to prevent any undefined variables from making their way through. So now that we have both our active state and a list of sites, we need to write the functionality to block those sites if our extension is active. For that, we're going to use a listener on Chrome web request onBeforeRequest, which will expect a callback with a details object containing information about the request. First, we're going to check if our extension is active through the toggleSitesActive boolean. If it's not, we're going to return early, an object with a single property, cancel, set to false. This tells Chrome to continue with the request just like normal. Moving on, the extension is deemed active at this point. So we'll have to go through the list of sites we've set and block the request if the URL being requested is in that list. For that, we just need a few vanilla JavaScript methods chained together. Let cancel equal toggleSitesList, split by a new line into an array, and then sum. Sum expects a callback function, with the only parameter being a single item in that array. For each item, we're going to generate a new URL object from the details web request object's URL property, and then return a boolean value. If that URL's hostname contains the single item from our sum filter of the toggleSitesList. Sum is an array method in JavaScript that either returns true or false, returning true if any of the items in the array pass the filter provided by the callback function. So in this case, if any of our toggleSitesList websites added in through our extension match up with the URL of the incoming request, that cancel variable is going to be true. And so now all we need to do is return back the same object we used earlier, cancel, and then true or false, depending on the value of that sum method. After that, the onBeforeRequest listener expects two more parameters. A filter object to determine what URLs will be listened to. In our case, we're setting that to all URLs. And then lastly, an array containing event type information, which for our extension, we'll just use the string blocking. Okay, that's the whole functionality to block a site, depending on our extension's active state and list of websites. The last thing we need to add to our background script is a listener for the Chrome storage onChanged event. Anytime that either of our storage items are updated, we need to update those global scope variables that determine whether or not a site is blocked. This listener expects a callback function containing changes and namespace parameters. We are only going to continue if the namespace is sync, since that's the method we're using. If the changes object contains a toggleSitesActive item, then that toggleSitesActive variable is now equal to changes toggleSitesActive new value, which is the change that was made to trigger this event. And we're doing the exact same thing for toggleSitesList. Okay, that's it. Let's add this script to our Webpack flow, compiling it to a dist.js folder, and running npm run dev to start that compilation. Now if we go back to our extension screen in Chrome and refresh, we can see that, well, nothing is displaying or happening in our extension. That's expected though. We don't have any front-end functionality tied to our popup HTML yet. But if we click this background page link in the extension description, a Chrome DevTools window opens up that lets us monitor and work on background pages or scripts. So if we run Chrome storage sync get here and output the results to our console, we can see that our toggleSitesActive item is set to false and toggleSitesList is set to just example.com, our defaults. Let's see if our work so far paid off. We can run Chrome storage sync set and set the toggle site's active value to true, and we can verify that by running the same get method that we just did. So this should mean that if we visit example.com, perfect, it's blocked by an extension. That means that everything we've programmed into our background.js file is working as expected. And if we run storage sync get, passing in toggle sites active as false, refreshing this site, it pulls up as expected. So now we have to get our pop-up tied to these values and let it update them using Vue. Opening up our popup.html file, let's cut out this whole wrapper element and put in a div with an app ID in its place. After that, a script element pointing to JS popup.js. Let's create that script under assets.js and open it up. This is where our Vue app initialization is going to happen. So let's get started with import Vue from Vue. But wait, we haven't installed that yet. Let's open up a terminal window and do npm install save dev Vue. Okay, that's good. And we'll need to import a single root component for our front end. I'm thinking popup from the current assets.js directory, components, popup.vue. Let's create that component now. And paste in all of the markup that we used to have in popup.html. Back to popup.js, const app equals new Vue, el is our app element in popup.html, and we'll use render, passing in our popup component to the create element method. We'll need to add this file to our Webpack flow, so a new JS call to popup.js, and output to dist.js. We'll also need to tack on this Vue method here. I'm not 100% sure why. It might be something new with Laravel Mix outside of Laravel projects, but it errors out without it. So now let's head back to our popup.vue component and start adding some functionality to it. First, let's create a data object that will hold our active state and our URL list. Both of these will have the same defaults that we used in the background.js script, but we'll quickly overwrite these. In the created method of our component, we're going to call Chrome storage sync get, just like we did to generate the global variables earlier. We want toggle sites active and toggle sites list. And in the callback, we're going to replace our data elements with the values from those two storage items. Just a quick note, even though we are in Vue, we can use the Chrome API extension in full, since this script is running inside of an extension window. We'll also create two methods, one for setting the state of our extension, and one for saving our list of URLs. For the state, we'll call it setActive and expect a boolean passed in. We'll set our active data state to the boolean, and then call Chrome storage sync set, setting the toggle site's active value as the boolean passed in. For the next method, we'll call it saveList. This is going to call Chrome storage sync set as well, updating the toggle sites list item to the value of the list data object. Both of these are going to ignore the callback functions, returning void. To tie in these methods, let's update our markup a little bit. We'll need to add click handlers to the active state buttons, passing in setActiveFalse for the off one, and setActiveTrue for the on one. For the text area that holds our URLs, it's going to use vModel and be attached to our list data object. And the save button will have a click handler as well, firing off the save list method. For the buttons, in order to tell what state the extension is in, we'll use this isActive class I've created to highlight it. For the off button, we'll set the isActive class on if the active state is false. And for the on button, if the active state is true. Okay, this looks great. So let's compile our assets with npm run dev and check it out. Going back to Chrome and refreshing our extension, let's open it up. We can see immediately that our Vue component is working. The off state is being highlighted, and the example.com default URL is showing in our site list. If we click on here, our state changes and the extension should be active, so let's test that. Example.com, and it's blocked. If we open up our extension and click off, refreshing the site, it's not. Perfect, everything is working as expected, and our Vue component is tying into the Chrome extension API. Let's open up our extension and try adding in some more sites to make sure this is working. Hitting save and turning the extension on. If we navigate to one of the sites we blocked, the requests to them are being stopped. And if we remove a site, it's showing up just as it should. Before we go, let's add in a visual element to our extension, which will help the user know immediately if it's active or not. First, we have to create an icon set. In the manifest.json file, we can use this icons object, which expects a few different sizes: 16, 48, and 128 pixels wide. I've added in these sample icons that I made to an images folder in our assets directory. There's also an off state for the 48 pixel image, and I'll show you how to use that shortly. Let's add these paths to our icons object in the manifest.json file. And add copying the images from the assets to the dist directory in our Webpack flow. After running npm run dev, if we go back to Chrome and refresh our extension, we can see that it now has an icon both on the extension page and in the toolbar up top. But that icon doesn't update whenever this state is active or inactive, which is what I'd like to do in order to quickly show a user whether or not the extension is active. If we head into our Vue component, this is an easy addition. At the bottom of our setActive method, we can call Chrome browser action setIcon. This expects an object consisting of a path to the icon that we want to use. In our case, that's going to be that 48 by 48 off image that I referenced a little earlier. But this path needs to be dynamic and update depending on the active state. So instead, let's create a new data object called icons. Active will point to the plain 48 by 48 icon, and inactive to the off icon. Now in the setIcon method, we can update the path to the icons object and determine the property value based on if the active flag is set to true or false. Running npm run dev to compile our changes, and we're good to go. Before we test this out, let's head back to our manifest.json file real quick. By default, we've set the active state of the extension to false, and so we should display the off icon instead of the normal one. Under the browser action object, we can set a new property called default icon and pass in that off 48 by 48 icon path. Alright, let's go back to Chrome, refresh our extension, and test it out. We can see immediately that our icon is in the off position by default. And if we open up the extension and click the on button, our icon updates to reflect that change, with everything else working just as intended. Alright, that's about it for this video. You've learned how to create a basic Google Chrome extension from scratch, use Vue to provide interactivity to a pop-up element attached to that extension, and call Chrome API methods from a Vue component. Huge thanks to my GitHub sponsors, YouTube Elite members, and everyone else who continues to support these videos. As always, if you have any questions about this or any other web development topics, please feel free to reach out to me in the comments or on my Twitter linked below. Thanks for watching.